Well, it's great to be here, and I want to thank Monica and ISSP for hosting me the last 4 months. I've had a wonderful experience here, and I hope we can continue the collaboration. I took a different approach to this presentation in talking more about the general ideas behind the intersection of values and science in risk governance or risk analysis. And I'm not going to be talking too much about the case of GMOs, but using it as a touch point as I go through some of these general ideas. But before I get to that, I'd like to introduce my research assistant, Tashani Williams, who just flew in from North Carolina, and she has been helping with the at-risk project on the gene-edited. So I'll be touching on that, but not focusing on it primarily. So these are my observations, and in the literature, there's kind of two views, at least two views, about how values and science intersect in decision making. And one view is that values are subjective and science is objective. These are kind of philosophical views as well, if you read a lot of philosophy. So the prominent idea there is we need to keep values out of risk analysis because it's an objective process. And the risk analysis is claimed to be the basis of regulatory decision making. So therefore, how is there a place for values? And because there is no space for values, does that engender more controversy and the exclusion of multiple voices? And here you have a story where it's more the dominance of technological elites making decisions, and who have their own biases, I will argue, in the following slides. The second view is that values and science are both subjective, in a way. Science can always be contested. There's always uncertainty. You can't prove safety. You can't prove a negative. There's never really zero risk. But the problem with that is that you get relativism. And then what place does science have in facts in the discussions? And then you get situations like in the US where there are alternative facts. I had to put that in there. And so is decision making then all about values? Does everyone's values count equally, which Dwayne touched nicely upon? And then sometimes you can get the dominance of fringe groups with the loudest voices that sometimes do make false claims that go against the predominant view of the scientific community. And I would say that the GMO story in the US, which I followed for over 20 years, really kind of follows the first path of narrative. And I think the same in Canada to a certain degree. Since I've been here, I've been studying the GMO's governance system in Canada. So here is another summary of it. A common view among GMO scientists is risk perception is that people are irrationally afraid and expect zero risk, and so we need to educate them. That's called the deficit model in a sense. And in risk analysis, there's no place for values or the concerns of non-expert publics, because we as the technological elites, or the ones who know the technology and the science, have the knowledge and the objectivity. But they do admit that there's a place for values in risk management, and that societal values can be considered in risk management, and that risk managers and governments do this. However, there's a problem with this, in that values are inherent in risk analysis, which I will argue in the next 4 slides, and that risk managers in government often profess to make decisions based on sound science. And so are values really being considered in an inclusive way in the risk management process? And that regulatory approval in the GO's case, especially, or GMO's case, is usually the final decision-making point, and choices about risk management are not really publicly deliberated in the US, or I think in Canada as well, in that process of decision-making. So that view, which is common among GMO scientists, and many scientists, not all, but many, especially on the upstream development side, really is problematic from a variety of perspectives and really excludes values in the discussion. They get lost. So here's my argument for why risk analysis or risk assessment even is a value-laden process. First of all, who gets to define what a risk is? This is somewhat problem definition, if you will, of risk analysis. Often our regulatory policies for GMOs or other hazards really focus more on the first order physical harms, health and environmental harms, the direct harms of ingesting something or coming in contact with something. They very seldom focus on the second order or more indirect physical health and ecosystem harms or benefits for that matter. They don't focus necessarily, decision-making and regulation doesn't necessarily include space for deliberation about the distribution of risks and benefits and equity and justice issues, as well as other types of risks. So we as sometimes risk assessors, I used to do risk assessment in the federal government in the US, we think of risk in a certain way, but other people think of risk as a social harm, a cultural harm, an economic harm. And I would have to say that both in the US and Canada, in the GO's case, we don't find much space where these other kinds of risks that are also valid can be discussed, deliberated, and assessed and weighed and in decision making. So I just, but the concern about that is that we go too far. So I put this cartoon in there, possible risks, alien invasion, city destroyed by angry monkey god, building eaten by giant pig. And then it says, well, he certainly does a very thorough risk analysis. So you can't really take this too far. You have to bound this in some way. And that is a huge challenge, is bounding the scope of the risks that we should consider in decision making, because it can be taken too far. I acknowledge that. A second argument for why risk assessment is value-laden is that safety is not a scientific concept. And that is controversial when I say it in some communities. Maybe it's not controversial here. But for example, you have a dose response curve. So you have a certain hazard. Oops, I'm sorry. I've got to get used to using the little, there we go. You have a certain dose of a pollutant or maybe a GMO food, and you have a response. And that response could be allergenicity or toxicity. Generally, our data is going to be feeding a ton of it to mice. And so our data is usually on the high doses and high response, because we can't wait 100 years or 10 years to see a low-level chronic effect for regulatory approval. And so how you draw the line is somewhat value-laden. It's a judgment, okay? But what's even more value-laden is, what do you assume down here, and where do you set a safety standard? Is this safe enough, or is this safe enough? So that's why I argue safety is socially constructed. The dose response curve is based on evidence and facts, if you will. But what is safe is a social concept. So therefore, who gets to decide that? Furthermore, in risk analysis, endpoints chosen is value-laden, the interpretation of data, what timescales you're using, the choice of the baseline. What is your control? Is, like in the case of genetically modified food, is it pristine nature, or is it conventional egg without genetically modified food? So what do you compare the risks to? And then also, when you're looking at costs and benefits, sometimes big regulatory decisions will have to include cost-benefit analysis. How do you count ecological harms and benefits? And that's a very difficult subject of ecological economics. So I want to just give you an example of that with something that it's not a GMO food, which is my case study. It's a GMO, though, which is a mosquito that was developed by a company, Oxitec, which is designed to mate with the wild type mosquito and cause the offspring to die in the larval stage. And they do this by a somewhat complicated molecular mechanism. So in the presence of tetracycline, the larvae will grow so that they can grow them up in the lab, and then release them. And they want to release predominantly males because females bite. And then the males will mate with the females in the wild, the sterile male, and bring the population down. So that's the idea. Now this has been released in the Cayman Islands, Malaysia, Brazil, Panama, and it has been approved in the United States by the Food and Drug Administration. So, and that was in 2016. They took a new animal drug approval process, which is another talk altogether, but I'm gonna just show you a point in the risk assessment. This is a graph from the regulatory assessment of it, and it shows a growth curve, survival rate of larvae over a number of days. And this is in, with no tetracycline. So there's a certain failure rate to this promoter and this construct that some of them will actually live without tetracycline. So you'll see some of them emerging, and you'll also see some survival of the genetically engineered females and males over time. The FDA's conclusion is the FDA found it as highly unlikely that the release of the male mosquitoes would contribute to the increase in dengue or other diseases. I forgot to say that this is to bring down diseases in the environment. Oh my goodness. Dengue and Zika. So very important technology that could have a lot of benefits. I forgot to say that. So again, the release would not contribute to transmission because they're males and they don't bite, and so they therefore do not transmit disease. But they fail to acknowledge in that sentence that there's about 2 to 5% of females that will emerge and will bite. And so, there is the point of uncertainty. Now, is that a huge risk? Probably not, but the fact that the language in the risk analysis is making a value judgment there and interpreting the evidence in a certain way. And then it goes on to say further, their environmental lifetimes are short, about 2 days, limiting their ability to interact with humans. Now, if you read this graph, this is 2 days right here. So you can see that 40% of them survive more than 2 days. The evidence in the regulatory assessment, and that's how a regulatory agency is interpreting that. So we wrote a paper in the Journal of Responsible Innovation, and we kind of picked this regulatory risk assessment part, and in all cases, the uncertainty was interpreted in favor of technology deployment. So that is why I say experts and non-experts alike exhibit biases in interpreting scientific information for attitude formation and decision making. We are people too, and we have the same cognitive biases that others do, and we bring our values to bear on scientific information just like a non-expert would. And this is called, it depends on what kind of literature you're reading, but it's called motivated reasoning, confirmation bias, availability heuristic, et cetera, et cetera. You might have read the book Fast versus Slow Thinking. That was the popular book by Kahneman that talked about these kind of biases in immediate versus long-term thinking. So some of the things that color risk perception, and I kind of put them in 2 categories, although it's more complicated than that, are dependent on the individual and the values they hold, like cultural theory, their cultural worldviews. And so Kahan and others have developed kind of a cultural theory of risk perception according to a hierarchical versus egalitarian worldview or an individualistic or communitarian worldview. And so this is just a nice cartoon about sort of what that means in non-technical language. And you find across a lot of different technologies, whether it's nuclear or GMOs, that the egalitarian, communitarian people perceive higher risk. And we as experts hold these worldviews as well as the public. So that's one thing in the interpretation of scientific information that comes into play. The other thing, it relates to more features of the technology, and Slovic and others have been really seminal in this type of risk perception theory. I'm sorry the graphics are a little off, it's just from switching computers. So, but he developed a scale along features of the technologies, a normal to a dreaded hazard. Some people say controllability is an element of that, versus familiarity, known versus unknown. So, and the highest risk perception is generally in the low controllability, low familiarity. So in a paper we wrote in 2015 in Journal of Nanoparticle Research, which has a social science section, we kind of divide this to the features of the technology system, the what, versus the feature of the individual. And so you have these kind of 2 different risk perception theories. We identified some other elements from qualitative work. I won't get into that, but it's even more complicated than this because trust comes into play. Sometimes knowledge comes into play. Risk benefits and the ratio comes into play. But just to tell you that it's very complex. So we all perceive scientific information according to our values. Whose values should count, how they should count, and when should they count. And that's what we're asking with this GMOs case study. Now, I've argued in many talks that these 2 kind of dichotomous views of only the science matters, the technocracy, the positivism, just the facts, please, versus the it's all about values, are both flawed in a way, and that we need more middle ground approaches to risk analysis and risk governance. And I call many models in the literature that you can find that sort of argue the same thing. And this is more science informed and values respected approach, and where you bring in multiple expertise and standpoints. And one model I particularly like for the risk assessment process, not risk management necessarily, is has been applied to that, but even in the risk analysis, the National Academy of Sciences in 1996 wrote this book called Understanding Risk that calls for the analytical deliberative process for risk analysis, where interested and affected parties are included. And I kind of like that term. I mean, it's still hard to scope inclusion, but it pretty much covers it. And that you would iterate between dialogue and deliberation with interested and affected parties and analysis with technology experts and risk scientists and so forth. So in problem formulation, you might have a wider public deliberation process, and then the analysts go back and do their work. They show the draft results, to the public, and they engage in a conversation about how to interpret the risk information. And they say, well, practically from a policy standpoint, I'm almost done, so I'm a tiny bit over time, I apologize. For decisions with unique and wide impact, that this would be something to deploy. So, we don't have the resources to do it for every decision, but if something is of high stakes, high uncertainty, unique, not familiar, not necessarily controllable, that it would be particularly important to apply this kind of process. And I served on the National Academy of Sciences Preparing for Future Biotechnology Committee last year, and we came out with a report, and we were able to recommend a similar thing for changing the paradigm for risk governance, including risk analysis of genetically engineered organisms or emerging biotechnology products. So you'd have an entry point when it comes into a government or a governance system, and that if something is assessed as being unfamiliar and complex, you would have a higher level of engagement versus if it's one or the other, versus if it's neither, et cetera. So I will stop there, and I just really want to thank ISSP again for hosting me and acknowledge, financial support, and Fulbright Canada for allowing me to be here over the past 4 months. And check out our center. It's a great center in addition to ISSP. So I don't know which one I like best. I'm not going to pick sides.